We already talked about what is a projectile in our previous video. In this video, what we are going to do is we are going to talk about projectile motion in quite a bit detail. Okay, so let's talk about it. Suppose I have a object, okay, let's say a stone maybe, okay. I have a stone and I am throwing this stone at a certain angle with respect to the horizontal, correct? So I am throwing this stone and then you already know that it will follow a certain trajectory like this, correct? Now this trajectory that it follows is parabolic trajectory, and I will derive what is the parabolic equation of the path. Okay, so that is the main agenda here. Okay, so this motion is what we are going to study. Okay, so let's put up the coordinate system, a reference frame you can say. Let's say this is our y-axis and this is our x-axis. Okay, now at this point I am throwing this at with a certain velocity, of course, and this velocity is u bar. Okay, the initial velocity, it is u bar, and let's say this angle is theta, the angle that the initial velocity vector makes with the horizontal. So obviously this angle that it makes with the y-axis will be 90 minus theta. Before we talk about projectile motion in detail, I want you to understand this fact. So the fact is that the motion in x direction will not be affected by the motion in y direction. What I mean here is that if there is a constant motion going on in x direction in the constant velocity, and if there is an acceleration in y direction, then the motion which is in the x direction will not be affected by the motion in the y direction. Okay, obviously it won't follow the straight path like this. Okay, it won't follow the straight path, but the thing is its horizontal velocity will not be affected. Only the velocity in the y direction will be affected, because the acceleration is only present in the y direction. This is the main important point. Now let's move to this projectile motion. Okay, so let's say u bar is the initial velocity vector. What I can talk about ux. Ux means the initial velocity vector's x component. So it is u cos theta, and uy is equal to u sin theta. Okay, so this is the y component. So as I told earlier, that acceleration is only present in the vertical direction. Which is that acceleration? Acceleration due to gravity, and that acceleration due to gravity is in the downwards direction. Okay, so here what we are going to do is we are going to take an arbitrary point. Okay, maybe this point. Suppose at this point the x coordinate is x and x, and y coordinate is y. This is y. Let me erase this so that you can see clearly. So this is y. Okay, so let's say this situation is after certain time t. So now what can I tell about the x coordinate? What is the distance covered in the horizontal direction? So the horizontal direction is ux into t, the distance covered. So x is equal to ux into t. But what is ux? Ux is u cos theta. So u cos theta into t. So what I can say here is x is u cos theta t. This is our first equation. Now what about the motion in y direction? So let me tell you, the motion in y direction is independent of x, motion in x direction, right? So here what I am going to do is I am going to use displacement formula, which is s is equal to ut plus half gt square, half at square. In this case a is g. So here now what I am going to do is s is equal to y minus y0, but here y0 is the initial coordinate, which is 0 of course, so it will be 0. So this will be uy. Okay, the component of the velocity in y direction is uy into t minus half gt square. Why minus? Because acceleration due to gravity is in the downward direction while u sine theta is in upward direction. Okay, so now what we will get here is that y is equal to uy into t minus half gt square. So you already got why I took y0 as 0, right? Because it is initial coordinate. So what is uy? So y is equal to uy is u sine theta into t minus half gt square. Okay, so this is my second equation. So now what I am going to do is I am going to get rid of this t. So how can I get rid of this t? I can just substitute the t from here. So x is u cos theta t. You already know this. U cos theta into t. So t will be x by u cos theta. So y is equal to u sine theta into x by u cos theta minus half g into t square, which is x by u cos theta whole square. So y is equal to x into tan theta. Here sin theta by cos theta is tan theta, and u will get cancelled. Minus half g x square by u square cos square theta. So this equation is a parabolic equation, correct? So if you look at the y, if you look at the y coordinate, so y coordinate will vary with respect to x in this fashion. Okay, correct? So this is a parabolic equation. So and this equation is called as equation of path. Okay, so this is the equation of path for a projectile motion.